Okay, so welcome again. We will start with a short introduction to Extend and CIVA for those who don't know us, even if some of you are already CIVA users. Well, I'll try to be quite fast on this part. I will introduce CIVA Script, it's a concept or feature, and we will show a few demo and use cases on how to use, why to use this feature. Okay, hello Nick for joining us. Uh, at the end of this presentation, so it should be about 1 hour, we will have time for question and answers using the chat tools that you should see on your window in the WebEx tools. Okay, let's start again with an introduction, and then we'll present you to this new feature. Okay, so maybe you already know us. Extend first and main activity is the distribution of the CIVA ND simulation software worldwide. We are in charge also of the technical support and the training sessions on CIVA. In terms of training, we also offer training dedicated to the reliability in ND topics, so which is not only on CIVA, but more generally on this topic of reliability in ND, including statistics. We also propose some consulting for those maybe who have CIVA or who have not CIVA, but who want directly results from us. We can provide consulting studies based on simulations, based on also trials if necessary. And our last part of our activity is a new product called Trendy that we have put on the market a few months ago. Trendy is a virtual training mockup for ND UT operators. So this is a different product. I will not focus on the Trendy today. The focus today is CIVA, and more specifically, a new feature of CIVA, which is a script feature. So CIVA is a simulation tools that can be helpful to design inspection, optimize inspections. The idea is to help you with simulations to prepare inspection scenario, to find the optimal settings, and to save physical mockups, to save physical prototypes, so to save time and money at the end when you design an inspections. You can use also CIVA as a way to expertise given results from the field. Sometimes it's complex to interpret. You can use CIVA to reproduce some field results and to help you to confirm or disprove a diagnosis, to help you, for instance, to understand a given signal, a complex echo, and to give insights for that to help the diagnosis. Qualification can be, in this context, it can be also really useful to use modeling because you can replace a lot of mockup tests by parametric studies and then study degradation factors, influential parameters. So you can maybe save mockups and save money when you are in this context. And generally speaking, CIVA allows to discuss and convince about ND maybe more easily because it provides a visual support and it makes technical discussion maybe more efficient. I hope you can all hear me okay. I don't know. Is the sound still okay? I have just a message from Ralph who says the sound is not so good. It's better? Okay. So I'll try to.
Yes, it's okay.
To be careful. Okay. Right. Okay. So CIVA is a ND simulation software dedicated to this domain of applications with different techniques: UT, guided wave, X-ray, eddy current. It also performs data analysis in UT. We have a research version, CIVA Experts, industrial version, and also a simplified version for teaching called CIVA Education. CIVA is developed by CEA, a research center in France, with a development team of about 30 people. CIVA UT, this module includes capability to compute beams and map beams, including conventional or phased array probes. You can see here beam mapping with different shots from phased array probes. You can also predict echoes, inspection simulation tools, predict A-scan, V-scan, S-scan, and so on. We also provide statistical tools to perform sensitivity analysis and POD curves calculation, as you can see here on the graph. It covers conventional UT, pulse echo, phased array, including TFM, tandem, TOFT. And also, finally, it can perform UT data analysis by loading real data files, such as Edify, Olympus, and the new one, TPAC Prelude data files that you can load inside CIVA to perform your analysis within CIVA UT. For other formats, we offer a plugin so that you can connect, also develop these connections to read your own data files and do analysis within CIVA. CIVA guided waves includes tools to compute dispersion curves, to compute the field on a cross-section of a component, and also to predict A-scan signals due to discontinuities or defects. Also sensitivity analysis, and you can cover different specimen shapes, different type of probes in your modeling. CIVA eddy currents also includes field calculation tools, impedance diagram tools calculations, and also inspection simulations, defect response simulations, here a probe tube inspection, bobbin probe case. It also includes sensitivity analysis and periodic curves calculation as the other modules. And it can cover various techniques, conventional eddy current arrays, remote field or pulsed eddy current. And finally, the X-ray allows you to reproduce photonic radiation in a component due to an X-ray source or a gamma ray source, including direct and scattering radiations. It also includes sensitivity analysis and periodic curves as well. X-ray, gamma ray, high energies source can be included. And you also have an add-on to perform CT, so tomographic reconstructions with a set of different algorithms available. Let's just open CIVA interface for those who don't know to give you an overview of it. So here, this is what it looks like. It's here a CIVA UT case. When you open CIVA UT, you have an access to a view of configurations. Here, a planar block with here in yellow UT transducer, shear wave probe, angle probe, and two defects represented in red here. And you have access to some panels to define your own parameters. Specimen panels for the test piece properties, its geometries that can be planar, cylindricals, or more complex CAD shapes, for instance, or nozzles, for instance. Your properties, so in this case of UT, acoustic properties, density, velocities, and possibly more complex attenuation or noise properties. Another panel to define the probe. You can define contact, immersion, single element, phased array. You can define your own probes. You can have different type of phased array, and some panels to define wedge, signal, pulse signals, etc. Inspections to define scanning and positioning. To do scanning, single line scan, raster scan. Okay. And panel for specific array settings if you have a phased array probes, and panel to define the defects. That can be planar defect or other shapes, elliptical defect, for instance. Like semi-elliptical like this, or let's say flat bottom hole, side wheel hole, other shape of calibration holes, volumetric defect such as spherical porosity, and so on. Okay, and then once you have defined all the parameters, you can run a calculation by pressing here the run button and analyze those results within CIVA. But the focus today of my speech will be CIVA Script, and CIVA Script is actually one way to use less the user interface of CIVA, is to drive CIVA without opening this graphical user interface. The objective of CIVA Script is to help you to be more productive, to save a lot of time, especially when you run large-scale simulation projects, in order to avoid you to repeat manual manipulations such as to repeat a lot of simulations together, to extract a lot of data. These two steps can take a lot of time if you have a big project. So scripts is a way to automate the whole process and so save a lot of time and be much more efficient. This CIVA Script feature is compatible with all CIVA modules, UT, eddy current, X-ray, CT, and guided waves. And we provide with this feature, with this optional feature, a tutorial to help you to get started with this tool. You can consider different ways, and there are different levels, let's say, to use CIVA Script. First of all, you can consider CIVA Script as just a simple call of CIVA offline, let's say. For instance, you can call CIVA from a command line interface or maybe from another software. This simple instruction here in a command line will allow you to launch CIVA offline. Go CIVA blackbox. This is here the launcher of CIVA Script. And here it will launch these configurations, myconfig.civa. By doing that, you will run and save these configurations without opening directly the user interface. So CIVA, myconfig CIVA, this was my initial example here. I will open it just to show you again that this file here is there on my C drive, no result for the moment. And if I type this command line here, I will be able to run this case without using the user interface. So you can call CIVA offline. So more precisely, you have to, of course, point precisely to the path of this launcher, which is in the CIVA folder. So in my case, it's here, CIVA 2020, etc., until go CIVA black box. And of course, you have to point the full path to your CIVA configurations ready to run. So let's copy this. Let's open a command line. Hop, I type these instructions, and this should run and save my configurations. I launched it. You can see that something happens. The process of running the CIVA calculation is running. This is a quite simple case, so it should be run in about 20-25 seconds. Okay, 25 seconds here, down. Okay, black box exit. The process is finished. I can check that. I will open here my folder. Okay, so here actually there is one new folder with the date of today and the time. And inside I have myconfig.civa, which is now saved with results. I open it and you can see now I have some results. A scan, B scan window that has been calculated without me to operate directly CIVA. So you can call CIVA offline thanks to this simple command line. This is the first level of using CIVA Script. Let's go one step further. You have also the capability not only to run and save the configurations thanks to a command line instructions, but also to modify an existing configurations by changing parameter values to another values, and maybe by assigning several values to these parameters or these parameters. And second things, this XML script file could also allow you to extract data, because the extraction of results may be sometimes a really time-consuming part of the manipulation of a simulation tool. So thanks to an XML script file, you can not only launch and run, but also modify driving a series of simulations and extract results. Let's see an example of XML script file. I will open that in a text editor. Okay. So here, this is a syntax, a basic syntax of an XML script file that can drive CIVA. This first example is just really the most simple one. This one actually is just made of a header line here, then black box key name. And here just have a single instruction here, which is the name of the initial CIVA file and the working directory in which you want to save the calculated CIVA configurations. So this XML file would just do the same as before, would just run and save the configurations. But an XML script file can go further, as I said. You can here include another section called changes that is able to drive one or several parameters and to assign it one or several values. In this case, there is one parameter here selected by this key name. Okay, this key name is maybe not obvious to know. So how to know which parameter you can control? Well, it's quite simple. You just have to know to pick up here in the CIVA menu. In this case, this is, for instance, the flow skew angle. I go in the relevant panel, right click, and it gives me this key name. It means this is with this name that I can control it through a script. Okay, and I can select another one if I want, another key name of parameters. Okay, it gives me this, and then, so in my case, I will assign two different values to the skew angle of my defect, 5 degree and 15 degree. Okay, and you can repeat that for a series of parameters by just putting several lines in these script files. Second, additional capabilities with the XML script. This is to extract automatically the results at the end. This is here in this extraction section of my XML script. Two types of extractions, actually. You have a simple type of extractions, which is the extraction of the max values, here with UT max in the case of a UT simulations. In this case, it will extract in a text file the maximum value of each simulation. Okay? But you can go further. You can extract all value also. I mean, all A-scan, all B-scan data, and so on, using this key name UT-full, and it will extract them in a chunk binary file called, in my case here, output.chunk. Okay, so two types of extractions. One simple text files for max data, let's say, and one binary file for full raw data of the simulation. How to launch this XML script? You can also do that thanks to a command line interface, for instance, with these simple instructions. Again, the launcher of CIVA Script, go CIVA Black Box, then the name of your XML script. More precisely, again, you need to point the precise path to code CIVA Black Box in the CIVA folder, and you need to point to the precise path to your script. In my case here, this is CIVA Script, myscript2.xml. I launch the last script I've shown you, because we are there, it's there. Okay? So again, I will show you that by copy this line. Okay, XML and run. So it should launch, it actually launches the same configuration as before, but now by changing one parameter value, the skew angle of the flow, and by assigning it two values instead of 0 degree as it was initially, it will run it with 5 degree of skew angle. This is here the first case. And once finished, it should launch it with 15 degree skew angle. So again, it should be about 25 seconds per simulation. Yes, the first one is finished. It goes to the second value, 15 degree. And it should save the results here in this folder, working directory, CIVA Script computed. Let's wait for the end. Okay, finished, done, up, in about a minute for the two simulations. So if I open CIVA now, I go in, up, computed, and I have two folders, one per simulations. I open the first one. It should be 5 degrees skew angle. Okay. Yes, actually, I can see here there is a skew angle for my first defect, which as a result lower the response of this first defect. Okay, compared to the initial case. And my second simulation has been done with 15 degree. Okay, skew angle. And this is the case here again. Okay. So it has done a kind of parametric study, but I've also asked to extract automatically results. Let's see, in each folder, as you can see, I have a text extraction with the max value, okay, for my first case. And I have a chunk extraction, which is a binary file that we'll be able to read afterwards to process the results. That contains all the data. You can see the size of this file. It contains all A scan, B scan content. And same for my second case, a text file and a chunk files that contains all raw data, because I asked with my script to export these results in the same shot. Up. Okay. Let's go again now one step further. Third level, let's say. After the simple call, after the simple XML script call, then, well, the idea is maybe to use another scripting language such as Python, not just to use one fixed script like this, but to build and drive in a given program this XML script file, but also to process the results you have extracted thanks to this XML script file, and of course, the most interesting is to repeat this process several times, because you will save time not only if you run a script for one case, but you will save time if you have a large simulation projects to handle, and if you can iterate the full process, if you can repeat the full process. So this is here, when you go to this level, that you have a real added value of CIVA Script. You can repeat for the full process for several times. It will help you to automate, to run several calculations, to run several analysis sequences. It will help you to go until an optimization or characterization study. If you are in the case of an optimization study, you actually need to first analyze results before launching new simulations. The idea of CIVA Script is that you can define your analysis criteria, you can process the results, and you can iterate loops that will monitor the parameters of CIVA depending on the initial results, in order then to converge to an optimal results and to perform an optimization study. To do the full loop, let's take an example. For instance, let's take the example of a UT simulation inspection here, immersion inspection, where your goal is to maximize the sensitivity at a given depth in this block. Okay, my criterion will be the response of a flat bottom hole at a given depth, and I want to optimize, so to maximize the signal reflected by this flat bottom hole at this depth. And I will use a script to optimize the curvature radius, so the focusing of my probe, to generate the maximum response. Thanks to CIVA Script, you can drive several iterations of simulations by running different curvature radius values, and depending on the results, you perform a kind of dichotomy in order to converge at the end to an optimal value. And you can even plot the results of the max here, the curve of the max, versus this curvature radius. Let's see this example in real. So I'll open the initial file here. This corresponds to this one. I open it in CIVA just to show you where we start from. Okay, this is a immersion UT case. I want to maximize the response of this flat bottom hole at which depths? At 50 millimeters depth. Okay, I have an initial curvature radius for my probe of 250 millimeters, and I want to optimize it to maximize the response. Okay, so I have defined a script to automate this. So I have defined a Python script for that, and I will show you this script allowing to do this loop. I've opened my Python script here. You can see it, CIVA Script tutorial ut1.python, okay, .py. Okay, this is my script I have developed. Typically, the script is made of three parts. The first part where you import some libraries, then a second part where you define your functions, and one of the core functions here that you will find maybe all the time, this is the write XML script functions these functions actually build your XML script that will itself launch CIVA. Okay, you can recognize that it prints the lines of the script using the syntax we have shown before with the simple script. Okay, other functions, and another important function here is one that will optimize the radius of my probe. It's you see there is a loop with the for and if instructions, and these functions call write XML script, but it will call it several times as an iterative process to find the results, analyze the results, and then optimize the value to give to this parameter. Last part of the script is the main execution with the input data for the user, typically where is CIVA saved, where is the initial file, where to save your data, and some parameters, maybe, for instance, to control your iterative loops. And then you launch the functions. Let's run it. So I've used it here in a Python development environment called Spider. Okay, so this is my case, but you could think about other ones. And I've launched it. Okay, first loop. Okay, I've proposed by default 7 values of curvature radius between 200 millimeters and 440 millimeters of radius. It calculates all cases. It compares the results. It finds an optimal, which is 240. Then it refines the variations around these values between 210 and 270. Second loop of iterations. It calculates the 7 cases, compares the max. Okay, it has found that 260 is the better. So now it refines again the variation step around this value. And I think it will stop after 3 iterative loops here. And it will tell you which is the best value. Okay, it tells you that the best value is 259 millimeters. So thanks to a kind of dichotomy process, it has run, you see, 21 simulations of CIVA automatically, and it has refined on its own the value of the curvature radius in order to converge to the optimal results, which is here plotted on this curve with a red cross here. Okay. By the way, it has created the CIVA simulations, so you can open it. It has put them in computed normally, according to my script. I can see my 3 iterative loops, and my best result should be at the iteration 3 and configuration number 3. This is number 3 here. And normally this one corresponds to the optimal results. Okay, I can open it if I want. This is my scan and my probe curvature radius here. This is corresponds to the radius of 259 millimeters. So I've defined an optimization function thanks to a script that has driven a set of, in this case, 20 simulations of CIVA, about 20 simulations. Once you are happy with your script, you may want to use it in a more larger scale. Maybe you want also to share it with your colleagues, and it can be more user-friendly. Instead of staying in a development of an environment of development, to have a kind of user interface also for the script. With Python, you can, for instance, use notebooks to make the use of the script easier for maybe for you at a later stage or for your colleagues. Okay, we have done this in this case. A notebook is a BAT file, BAT file. I will open it. Really simple to define once you have defined the Python script. Okay. Okay, you can see it. It provides a kind of introduction with text and images to introduce your case and your script. Okay, so we have here an image of these inspection configurations. Okay. Then with this instruction, you import the Python script, the code.py in this notebook. Then you will find the input data of the users, so the CIVA home directory, and as we have shown before, the parameters there is in this script to drive the iterative loops, and then it runs the functions. So I will launch it. I will maybe just close the results to avoid any conflict. And maybe, for instance, I will change here only 5 steps of simulation instead of 7. We go faster, run all. So this is the same script as before, but just called from another way, from a kind of user interface, to show you that you can also share easily the script you have coded in a quite efficient environment for the use of this script. Okay, so again, 3 iterative loops with only 5 simulation each time now. Okay, first loop, second loop, it has found that it was around 260 that the best value is obtained. And at the end, it should find the same results because it has run it here around 260 millimeters of curvature radius. There we go. It provides the results of these new iterative loops, and it tells also that my optimal curvature radius is 259 millimeter. So automation of several simulations, automation also and direct analysis of the results. In this case, I've analyzed the max of my echo, optimization functions, all that built in a simple program, and that you can also launch with a notebook at the end if you want, especially if you want to share it. Next use case, another interest of the script is that you can export all data from a simulation, so that maybe you can customize the post-processing you want to do on this data, the analysis. Indeed, so when you use CIVA, it provides the results in a given analysis environment, but maybe you want to adapt this analysis to your own context. With CIVA Script, you can export all data. We have seen that in a chunk binary file. And then, thanks to your OS programming tools such as Python, you can read this data and define your own post-processing functions. For instance, let's see an example here with the beam UT simulations, where we have customized analysis by not only plotting the beam mapping, something that you can do already in CIVA, of course, but by putting, for instance, here a cross on the location of the maximum. Here you can see something that you don't have by default in the CIVA beam mapping. And we have also put here the value and the location of this maximum with these figures directly plotted in my charts. Okay, let's see this script in operation. It corresponds to beam obtained with shear wave angle probes. So let's open my script. First in Spider. Okay, here, tutorial 2. Again, first section of my script, import some libraries. Second section, definition of functions. So again, one core function is the one that drives the XML script that is driving the CIVA calculations. And another important function here is the one that reads the chunk file. The chunk file is the one that you have extracted from the XML script. So this is the results. To read them, we have CIVA provides Python readers, and then you can read the data, and then thanks to this you can plot or prepare your own analysis functions. In this case, it's called beam analysis. It does some plotting of the maps of the beam, plus also, we'll show you, it crosses the location of the max and so on. It also creates an Excel spreadsheet to extract the most important value of the beam analysis, and so on. And then the last part of the script is the execution with input data. In this case, this is the angle of the beam you want to compare. So the angle of the shear wave probe, and then it launches the different functions. Let's run it. So in this case, it's 4 angles, 40 degrees, 50 degrees, 60 degrees, 70 degrees shear wave angles. So we have changed the angles of refraction of an initial UT probe, and we will compare the beam in terms of beam mapping, location of the max. Okay, then calculation and beam extraction, beam plotting, and you can see here we have customized our beam mapping with a cross, and here the information of the location of the max for 40, 50, 60, and 70-degree case. Okay, let's open the files. It should be again up in CIVA Script folder, computed. Okay, T60 for instance. By the way, of course, it has created the CIVA files and saved them. Okay, so you see more or less the same beam mapping in CIVA, but in CIVA you don't have the cross to identify the location of the max. So we have done this by customizing our analysis thanks to Python script. We can check also that it has created also an Excel spreadsheet, which is there. Okay, that here keeps the angles, the value of the max, and the location of the max for each angles for an easier and faster, much faster analysis and automatic reporting. Again, you can also want to provide a user interface to your script, so you can create a notebook of this. I'll show you a notebook for this second script. Okay, introduction, import of the Python code, input data for the users, location of CIVA, the angles I want to compare. So maybe, for instance, here I will change and start from another CIVA file. The initial one was 2 megahertz. Here, this one corresponds to a 3 megahertz probe, UT probe, and I will compare, let's say, only 45, 60, and 70 degree. So you are not, of course, limited to with a script with to a single case. You can use it for several cases if your script has is made correctly for that. So I will run this new up. Yeah, of course, the CIVA file is open. There is a conflict. Okay. Okay, in progress, it works better. I have a question from Mastan Papanabwana. I will answer at the end of the meeting. We will have a chat sessions, question and answer sessions at the end. So in this case, it should run three different angles. Okay, at 3 megahertz, you can see that at this frequency, the maximum is further 45 degree, 60 degree, and 70 degree, with also kind of local max in the near field, also 10 at these angles. And I've done that with the same script as before. Okay, so you can imagine that if the script is correctly done, and you can use it for a lot of cases, and it can help you to save a lot of time. Well, let's also mention also another interest of CIVA Script. This is the fact that you can drive not only numerical parameters, but all parameters of CIVA. We have driven until now the curvature radius of a probe. We have controlled also the refraction angle. Okay, this was 2 examples, but you can also imagine with the script to control the full probe parameters, to control the full specimen properties, including its CAD definition, for instance. You can go further than just sweeping parametric and parameters values. Okay. For instance, in this case, we have compared 4 different detector files in X-ray simulations. So we add initially 4 detector definition in the XML files, and the script has managed in a single loop the simulation of these 4 detector files, and I've compared them and I've extracted the profiles of the optical density profiles along here, these lines. So there is here, you can see IQI, and in order to superimpose and compare automatically their profiles like this. So you can go further than just sweeping parameters also in terms of control of CIVA inputs. You can also control more general parameters. Another interest of CIVA Script. Right? Okay, so this is my conclusions. We have seen CIVA Script, so which is an optional tool in CIVA that allows you to drive CIVA calculation without using the user interface. You have seen that you have different levels to use CIVA Script, simple call, or an XML script to also do parameters sweeping and results extractions. And the real added value is when you do a full loops of this by using your own script, for instance, using Python, to run a large series of simulations, a large series of analysis, and maybe to run auto optimization loops and so on. Or maybe also, because you can extract all data, you can customize also and automate your analysis works. You can imagine by this way to save a lot of manual manipulations and so save a lot of time where especially you are involved in large-scale studies. You can also imagine connect CIVA with maybe other software, maybe other simulation software environments, thanks to this possibility to call CIVA offline. So these are the things you can imagine with these new features CIVA scripts, and I hope you will be able and will be interested in using these new capabilities of using CIVA. As I said before, to help you to get started with this feature, we provide a tutorial, including 5 examples to help you to see the capabilities and to see some examples of scripts. The 3 of them has been presented in this webinar. Right, so thank you for your attention. It's now time for questions. So I have, I think, already a few questions that you have asked me through the chat tools. I will try to answer you. So I will share them first. So I have a first question from Mastan Papanabuana. When we are using sectoral scanning at 30 to 70 degrees, how to combine all beams together in one figure? So if you want to do beam mapping from 30 to 70 degrees, I guess. So you know that already within CIVA you can accumulate all the fields. If you want to do the same with CIVA Script, well, it means you need to extract from each angles the beam maps for each angles. Once you have all this data, this is like a matrix that you have in your Python script. It's just then a plotting of the information you want to plot. You have all the raw data available for that, and then it's a question of just coding the beam mapping you want with the data you have. You have a matrix of all results, and then of course this is your job to plot the sector scan and maybe to accumulate all the max in the same way. The important thing is that thanks to CIVA Script, you can export all angle, all shot in a given matrix, and that you are able to read this matrix thanks to Python readers that are provided with CIVA. Based on this, you do what you want with the data you have. Another question from Nick Braley. Is there a computational efficiency improvement through not needing the GUI? Yes, that's true. It's not the main thing. The main thing using CIVA Script is to save time due to the fact that you don't do manual manipulations to change different calculations or to extract results and analyze results. But there is also you save also some calculation time because you don't launch the user interface when you run a CIVA simulations through a script. So you save a little bit of memory or Java and so on, and you save also an amount of time of that. But this is not the main thing. I don't know in percentage, but maybe you save 20-30% of calculation time, something like this. It depends how many cases you run, and depends the module and also the time it takes if you open it in the user interface. But there is a gain somewhere. Other question? Is it possible to reduce complex inspection simulation time by using these scripts? Complex inspection simulation time. This is a little bit what I said to Nick. Yes, using running a simulation through a script save a little time compared to running the simulation in live, even if this is the same thing. But this is not the main interest. The main interest is to be able to process the results progressively and to iterate on these results and build some loops and build your own analysis and avoid to open the interface to extract the data. But yes, you will save some time, let's say. Is it only available with CIVA 2020? Yes, it's new features that has been developed and is available in CIVA 2020 SP2. So it's not even SP0. It has been just released 2 months ago in CIVA 2020 SP2. It's not compatible with previous version. Any other question? Is there a manual for the scripting available? Yes, good question. I will show you. There is a user manual, which is here in PDF, which is quite complete, that describe the main things, the basic things, gives first examples to show how to use it mainly, how to pick up the parameter name if you want to include some changes of parameters in your script. And then you have pages that describe the precise XML syntax to extract, to change, and the different case. Also, the connection with Python readers. So you can see more than 30 pages, and you describe each syntax of the XML script syntax of that. And then at the end, you have some example of XML script. Okay. So this is the XML layer of the script, but of course, after that, if you want to change everything, you will do maybe Python, and Python is not itself in CIVA. Python is your own code, but we provide some examples with a tutorial, and the tutorial includes Python script itself. So the tutorial includes also how to use XML script and in a Python script file. So yes, we provide all this documentation, quite complete user manual, especially to define the XML script syntax, and then a tutorial with 5 examples that provide examples on how to use CIVA script embedded in a Python script. Is it available for non-CIVA 2020 SP2 users? Yes, you talk about the manual. I can send it to you, Ralph, no problem. So that you can have an idea on how to implement this. I can send you both PDF files, but if you want to use it in CIVA, you will need to update to CIVA 2020. But I'll send it to you. Other questions? So I've focused my webinar on CIVA UT, but of course, as I said, it's compatible with also X-ray, CT, and edit current modules. Same idea, but of course. So if there is no other questions, we may stop this session. As I said at the beginning, we will put this session on YouTube, so you can podcast it afterwards if you want to see it again. We will send you the link to this YouTube podcast in a few days. And of course, don't hesitate to contact us myself or our dynamic address contact@extend.com if you want to ask questions about these new features, this option. And I hope you will be interested in getting these new features in your license to be able to use CIVA Script for your own project.